video, I would like to share something about population of energy levels and Einstein's coefficients. First, let us see what is meant by population of energy levels. Under normal circumstances, higher the energy level, lesser the population and lower the lifetime. Under some circumstances, a system can be constructed so that there are more atoms or molecules in an upper energy level than is allowed under conditions of normal thermodynamic equilibrium. Such an arrangement is called a population inversion. When a population inversion exists, an upper state system will eventually give off a photon of proper wavelength and drop to the ground state. This photon can stimulate the production of other photons of exactly the same wavelength because of stimulated emission of radiation. Thus, many photons of the same wavelength and phase can be generated in a short time. This is light amplification by stimulated emission of radiation, or in short, laser. The number of atoms in the nth energy level under thermodynamic equilibrium is given by Maxwell-Boltzmann equation law as n of n is equal to n naught exponential minus of En by kT, where n naught is the number of atoms in the ground state, k is the Boltzmann constant, and T is the absolute temperature. So in this diagram you can see this is the lower energy level E1, and if this is the next energy level E2, under normal condition the lower energy level will be more populated than the upper energy level. So this is the normal distribution. In population inversion condition, the upper energy level will be more populated than the lower energy level. Now let us see what is Einstein's coefficients. Einstein derived an expression that relates the rate of absorption, spontaneous emission and stimulated emission. Einstein coefficients provide a measure of the probability of absorption or emission of light by an atom or molecule. Consider two energy levels E1 and E2 with populations N1 and N2 in an atomic system. At thermal equilibrium, E2 is greater than E1 and N2 is smaller than. First, let us see what is meant by stimulated absorption. The atom in the ground state E1 absorbs energy density of incident radiation rho nu and goes to the excited state E2. The number of induced absorption transitions per unit time R12 is equal to N1 B12 into rho nu, where B12 is the probability of absorption transitions per unit time, N1 is the number of atoms per unit volume of the medium, rho nu is the energy density of incident radiation. In this diagram, see, this is a lower energy level E1 where the atom is, and if an incident photon having energy which is equal to the difference in energy between E2 and E1 is incident, this photon will be absorbed by the atom and it will go to the upper energy state. This process is called as stimulated absorption. Next, let us see what is meant by spontaneous emission. The atom in the upper energy state cannot remain there forever. It has a certain lifetime. It will drop back, it will come back to the original energy level. So when it is coming back on its own, it gives out the difference in energy as a photon. So this process is called as spontaneous emission. So the atom passes from higher energy state to the lower energy state spontaneously by emitting a photon of energy h nu. This is a downward transition. The average number of atoms undergoing spontaneous transitions to state E1 per unit time is given by R21 spontaneous is equal to A21 N2, where A21 is the probability of spontaneous emission transitions per unit time and N2 is the number of atoms per unit volume of the medium. Then let's see what is stimulated emission. In stimulated emission, a photon having energy E which is equal to E2 minus E1 stimulates an atom in the higher excited state E2 to make a transition to the lower energy state with the emission of two coherent photons. The rate of stimulated emission is R21 stimulated is equal to N2 B21 rho nu, where B21 is the probability of stimulated emission transitions per unit time. So here, if a photon is incident, that is stimulating the atom to make a downward transition. And when it is coming down, we get two coherent photons. The derivation for Einstein's coefficient. At thermal equilibrium, the rate of upward and downward transitions must be equal. N absorption is equal to N spontaneous plus N stimulated. This is the upward transition. These two are the downward transitions. N1 B12 rho nu is equal to N2 A21 plus N2 B21 into rho nu. Bringing the two terms with rho nu on one side, we have N1 B12 rho nu minus N2 B21 rho nu is equal to N2 A21. Rho nu is taken common outside. The two terms N1 B12 and N2 B21 are taken together is equal to this term N2 A21, from which we can calculate rho nu as equal to N2 A21 divided by N1 B12 minus N2 B21. Dividing both the numerator and denominator of the right hand side by B21 N2, we get rho nu is equal to N2 A21 divided by this term B21 N2 and N1 B12 minus N2 B21 divided by B21 N2. So this term N2 and N2 will be getting cancelled and you get A21 by B21. So that is put here, divided into 1 divided by N1 by N2 into B12 by B21 minus 1. From Boltzmann distribution law, the number of atoms in the excited state Nn at a temperature T is given by n of n is equal to n0 exponential minus of En by kT, where n0 is the number of atoms in the ground state, Kb is the Boltzmann constant. Number of atoms in the first and second excited states can be written as n1 equal to n0 exponential minus of E1 by kBt and n2 is equal to n0 exponential minus of E2 by kBt. n1 by n2 is equal to n0 exponential minus of E1 by kt divided by n0 exponential minus of E2 by kt. Hence, we get n1 by n2 is equal to exponential E2 minus E1 by kt. We know E2 minus E1 is equal to h nu. Therefore, n1 by n2 equal to exponential h nu by kBt. Substituting the value of n1 by n2, rho nu is equal to A21 by B21 into 1 by n1 by n2 into B12 by B21 minus 1, and we get rho nu is equal to A21 by B21 into 1 by exponential h nu by kt into B12 by B21 minus 1. Comparing these two equations, we have the Planck's law radiation rho nu is equal to 8 pi h nu cube by c cube into 1 by e to the power h nu by kt minus 1. We have the term A21 by B21 is equal to, in this equation we have this A21 by B21 is equal to this term 8 pi h nu cube by c cube, and we have this term B12 by B21 is equal to 1, which tells us that B12 equal to B21. Results, what we can understand is the stimulated emission rate is the same as absorption rate, that is only B12 equal to B21. Next, since the ratio A21 by B21 is proportional to nu cube, the spontaneous emission increases rapidly with energy difference between the two states. And third point, if A21 by B21 is much less than 1, the stimulated emission will be predominant in producing laser action. Thank you.